Good day, I'm Fernando Manalo from ECE42, and today's experiment is for the experiment 6 in laboratory of the robotics lab. Uh, Laboratory activity number 6, accelerometer. And the objectives of this experiment is to enable the student to control the angular displacement of a robotic arm using the accelerometer, but in this case, we will be using 3 servo motors, and to create a computer program user interface to display data coming from the Arduino. And now let us look at the sketch. And here is my program, and I included the Adafruit MPU6050.h because I am using an MPU6050 accelerometer. I also included the Adafruit sensor.h library, wire.h library, and servo.h library. Then here I set the 3 servos XYZ, and then I set the Adafruit MPU6050 to MPU. Now in this loop, this will check whether my MPU is connected successfully. And here, this will check if the Adafruit MPU6050 is connected. If it is connected, it will print MPU6050 found, and if it is not connected or there is a loose connection, it will be failed to connect. Then I attached my servo X to 10, Y to 9, and Z servo to pin number 7. Then wire that begin and MPU that begin, this begins, then this starts the accelerometer. And here are the ranges for my accelerometer. I set it to 8G, 500 degrees, and 21 Hertz. Now, in the main loop, sensors event gets the following. A is for acceleration, G is for the gyroscope and temperature. And MPU.get event puts those values into A, G, and temp. But in this case, we will be using only the A, which is the acceleration, and for a triple axis. And I set 3 integers, X value, Y value, Z value, and I set it to XYZ. Now the library outputs -10 to 10 based on the position of the accelerometer. So I mapped it to 180 to 0 for all the ranges, and then I write it to my servo motor for the XYZ. And this simply prints out the values or the degrees in the serial monitor. And now I will upload it to my Arduino Mega 2560. So it's uploading. Now I will switch cameras. And as you can see, it is done uploading. Now here is my setup. To test if the program is working properly, I set this servo for the y-axis. This is the x-axis, and this is the z-axis. And as you can see, the z-axis is currently down as my accelerometer is simply laying down. Now I will test the y-axis and the x-axis. And as you can see, the z-axis is now up. If I put it down again, it is down. And we can also see it in the serial monitor. And here is the serial monitor. As you can see, the current X value is 81 degrees, or which is close to 90. And as we are almost level for the X axis, but on the Y axis, it is 162 degrees, and the Z axis is 126 degrees. Now if I move this up, as you can see, it turns to almost 90, as I can balance it to perfect 90. And the Z axis goes back to closer to 0, which means it is stable. And here in the setup, if I move the accelerometer in the Y axis, the Y servo rotates. As you can see here, the Y servo rotates. This one. Do it again. It's following the movements of the accelerometer. Now for the X-axis, if I turn it forward, it follows it, and if I turn it back, this is the X-axis servo. Now for the Z-axis, if I put it down, it follows. This is the Z-axis servo. And as you can see, here are the values, and it changes if I move the accelerometer. Now to test it again, I will move the Y-axis, the X-axis, and the Z-axis. This servo is simply lagging, as it is one of my older servos, and these two are new ones. And as you can see, it's working properly, and I can control. And that concludes that my sketch is working properly and my setup is working properly, and I have successfully finished the objective, which is to control the angular displacements of the servo using the values gathered from the accelerometer, and I'm also able to show it in the serial monitor. And that's the end of today's experiment, and